Dear students, welcome to another lecture on elements of machine design. We were discussing the design of socket and spigot joint, which is normally called as cotter joint. This cotter joint is a temporary method of joining two rods. Cotter joints can be quickly assembled as well as disassembled. The taper we have seen is 1 in 24 or 1 in 48. In extreme cases, it can be 1 in 8 also. The taper is provided on the on the cotter for two reasons. Due to wedging action, it ensures the tightness of the joint when it is in operating conditions, and it prevents loosening of the parts. You see, if any gap is there, the cotter will go inside because it is tapered, and it will make it more tight. Secondly, due to this wedge shape or the taper shape, it is easy to remove the cotter and dismantle the joint. So these are the advantages because of which the taper is provided. The taper of cotter as well as slots on socket and spigot joint are on one side. See, there is no specific advantage by providing taper on two sides. So it is only provided on one side. Then we yesterday was talking about the clearance. The clearance of 1.5 to 3 millimeters is provided in the slot and cotter, and this clearance is necessary to make the joint more tight. Okay, when the cotter is driven in the slots, the two rods are drawn together until the spigot collar rests on the socket collar. Okay, the amount by which these rods are drawn together is called the draw of the cotter. You see, you may be asked one question about on the draw of the cotter. Here is the definition. The amount by which the rods are drawn together is called the draw of the cotter. You see, these rods are drawn together until the two collars, one is spigot collar and the other is socket collar, they touch each other and rest on each other. Then applications we have already seen. You see, the joints between piston rod and crosshead of steam engine, joints between the slide spindle and fork of the valve mechanism. See, in Google you can Google these items and you will find. See, I cannot be showing all the pictures. Yesterday I showed you many pictures. Joints between piston rod and tail or pump rod. And foundation bolt. There are cotton foundation bolts also. You have studied in mechanical working drawing. Okay, these are the typical applications of cotter joint. Okay, coming back to our problem that we were discussing, we were designing the um, design of socket and spigot joint. First, to find out the diameter of the rod. Okay, how did we design it? We have designed it considering the rod, failure of the rod, intention. You see, it is strong in compression, therefore we consider only tension. So the area, how to draw it? You see here, see, you make a circle, you hatch it, you put the diameter D. Okay, now the area A is given by pi by 4 d square. This is the formula of any circle. Okay, and then the strength equation sigma T, that is tensile stress, is load upon area P upon A, that is P upon pi by 4 d square. So here you know what is P. It will be given sigma T, you know, only unknown is D, so you can find out D from this equation. Okay, so yesterday we have seen this. Okay, second, design of spigot end. How do you design spigot end? It is designed considering failure in tension. It is weakest in tension against the slot, weakest section. Where it is weak, it is weak in tension. Here it is strong in compression, so we don't consider compression failure, only tension failure we will consider. It is weak in tension. Okay, so you see here, 1 minute. See, we have to write the equation of the for the area of failure. This is given by pi by 4 d1 square minus d1 into t. You see, d1 is the rectangular area. Strength equation will become sigma t is equal to load upon area. Area is pi by 4 d1 square minus d1 into t. P is the load. Either it can be tensile load or compressive load also. Okay, and this area is directly put from the top. This is see here, these are not known and d1 is not known, t is not known. So there are two unknowns in one equation. You see, for two unknowns, two equations are needed. So what to do? We have to go to an empirical relation. Empirical relation, we will use it. You see, empirical relation, we will say take it as t is equal to um, zero point 0.3 times of d. See, empirical relation, this relation, empirical relation means over the number of years, because of experience, people have found out that it should be like this. Okay, this is empirical relation. Okay, that means in that case, what happens? This equation becomes p is equal to, see, in this, is substitute instead of t 0.3 d. Okay, d is already known. We have found out d is the diameter. Okay, so thickness can be taken as 0.3 times of d. And if you substitute in this, only one unknown will be left. That d was found out, and d1 only unknown will be there. Okay, in this equation, one unknown. Therefore, substituting this, we can find out what is the value of d1. Okay, next. Now we have found out d, we have found out d1, and we have to find out t. These three values we have found out till now. Okay, d is the diameter, d1 is the diameter of the spigot, and t is the thickness of the cotter or the slot. Okay, now come to the equation. See, this is the rod diameter d, and that is also rod. Okay, and that is the thickness of the slot or the thickness of the cotter, that is t. And d1 is the diameter of the spigot. Okay, and these values we have found out. It is a tensile load we have considered. Rod is considered to be failing in tension, and spigot, and this is the spigot collar. Now that is the spigot collar is in circle like that in the side view. In the front view, it is shown as rectangle. Okay, this is again, this is, if it is compression, it is pressing. This spigot collar is pressing against socket collar, and that is the area where it is crushing. Okay, so and now what we have to do is, You see, if you want to design the spigot collar, the diameter D2, I will show you how the area will be. You see, design of spigot collar. Due to the compressive load, the whole load is taken by the spigot collar. The area of it is considered to be crushing failure, and that is the area. And you see, the area of contact between spigot collar and socket collar in crushing, that is the circumferential area. See, that is the area in the side view where it is crushing. Okay, you know, you have to write this, draw this formula, and then you have to show the diameters also. The larger one is D2, smaller one is D1, and the thickness is T1. See, you should show in this figure, it is not shown the diameter. This is D1 and this is D2. We should show that. And the um, uh, by looking at the figure, you will be able to write the crushing area or area of failure. Okay, that is pi by 4 D2 square, that is outside diameter, outer circle minus inner circle. So pi by 4 d2 square minus pi by 4 d1 square. That is inside the bracket. If you take, it will come to like this: pi by 4 bracket d2 square minus d1 square. Okay, this is the formula. Okay. Now coming back to our figure. So till now what we have found out, we have designed the rod considering the tensile failure, and we have found out that it fails at here, and we have considering the tensile failure, we found out D. And then considering, we have found out the spigot diameter considering the failure in across the slot where the slot is. uh, See, D1 we have found out. Okay, that is also considering tensile failure. And then in the same equation we found out T also using the empirical relation. And then see, D1 and D2 both we have found out using the failure. And then see, some people take T to be 0.5 or 0.3 times of D. Some people take it D1 by 4. You see, T is equal to D1 by 4. You see, this is not like mathematics, where everybody will get the same value. If somebody takes T to be 0.3 D, he will get one value. And if some other person takes T to be D1 by 4, that is 0.25 times of D1, they will get another value. It is absolutely okay in design. It will not be exact values. Some people take, 0.3 times of D. Some people take it is 0.25 times of D or D1 by 4. Okay, both of them will get different values. So it is not that only one set particular value will be correct. Okay. Now, see, we have designed, we have to design this spigot collar. The spigot collar is crushing against the socket collar. That is the socket collar where my mouse pointer is. Now this is a spigot collar. These two are crushing, considering the compression failure. See, now this crushing area we can write as pi by 4 d2 square minus d1 square. Okay, that is the area for the crushing failure. And okay, coming to this figure, this is the figure that we have been using it. See, now this cotter and this spigot in this place, because cotter is considered to be strong. Considered to be strong means whichever we are designing, that should be considered as weak. Okay, this cotter is strong, it won't fail. That is, let us assume, because we are not designing cotter now. So spigot, that spigot in that area, that material there, it will be crushing against this cotter. Okay, why? Because it is being pulled with the load P. Okay, that load, that is the see, that is the rectangular area against which this material will be crushing against the cotter. Okay, now if you see in the figure, you see D1 is the diameter of the spigot and T is the thickness. So this is the area. You can hatch it also. Instead of showing like this is the crushing area. Okay, and the crushing area, the area will be now what? Area A is equal to D1 into T. Okay, that now sigma C, this is the crushing stress, is load upon area P upon D1 T, P1 upon A, that P upon A, that is P upon D1 into T. Okay, this D1 we are getting another value. Actually, this portion we have covered before, considering the crushing area of the collar. Okay, and then here we are getting a value of D1, and that value, there are two values. You see now two values of D1 are got, one using equation B, another using equation C. Okay, and this thing that we have solved is for D2. Okay, you see where we have found out D1. Yeah, using this equation B, we found out what was the diameter of D1. Here again D1 we are getting. So the above two values, whichever is the larger value, that should be taken as D1. Okay, otherwise it will fail. Okay, now in this, okay, we have considered this. Okay, coming back to our figure, we have found out the diameter initially for considering the tensile failure, diameter of the rod. Then we have considered diameter of the spigot D1, considering the failure of the spigot across the slot here. And we have found out the diameter of the spigot collar. We have found out that is D2. And then we have considered the crushing of the spigot against the collar, and there also we have found out another D1. Whichever is the greater of the two, that we have taken as D1. And then this spigot collar, this spigot collar, we have considered crushing and in tension, in compression, if you say take, if it is crushing, in tension it won't be crushing. Okay, that is the length, it will be shearing. If you are seeing, see, along the circumference, you see, if okay, along the circumference it will fail. You see here in this figure, the in this figure, the inside diameter is D1, and the along the circumference of that it will fail. You see, it is shown by zigzag line. Actually, here they have shown by shearing area. That is not the shearing area. This in this figure it is shown wrong. Okay, that is the zigzag area. That is where it is shearing along the circumference. The length of the circumference is pi d1, and thickness is t1. So the area of this will be pi d1 t1. T1 is the length through which it should shear. So that ring will come off. You see, that happens in compression, compressive load. Okay, and considering the spigot in shear. Uh, Okay, you see that is the circumference where it is shearing, and that is wrongly shown. Some mistakes are there in this book. Okay, and along the circumference, the length is, because it is inside circle, it is pi d1 and the thickness is t1. See, that is the area. So in this figure, they have shown it as 2 d1 t1. It's not 2, it should be pi d1 t1. You see, you keep in mind that you see there is a mistake here. Okay, and uh, you see, actually they have shown as double shear and the rectangular area diameter they have shown. Okay, see now that is the shear stress. It is failing in shear. Shear we take it as tau. Tau is load upon area. Load P upon area, that is P divided by pi d1 t1. That is the shear area. Tau will be given, P will be given, and we already know d1. Okay, so only one unknown is there. Tau, P, d1 are known, t1 is unknown. From this we can find out what is the. Is this not 2? It is pi. This is wrong. I'm telling you, you please pay attention. This is this the and the circumference, it is failing. So the length of the circumference is pi d and the thickness is t. So the area will be pi d. From this equation, you can find out the thickness of the spigot collar T1. Okay, so in this figure, now we have found out D, we have found out D1, we have found out T, and we have found out D2 also. Now we have found out T1. So these are the things that we have found out. Okay, almost the spigot. This is the spigot. All dimensions we have found out. Oh, yeah, one thing is left, that is A, this area, this length A, that is to be found out. Okay, so we for finding that, what we see is, you see, this is the car, this is the, you see, if we are pulling it in tension, this cotter is there. Okay, and this spigot end, that will be, say, for a length of a and for a distance of d1. Okay, this area should shear off. If it should shear off, see that cotter is resisting. Okay, that cotter is in the middle, so it should shear off on two sides of the cotter, this side also, that side. Shear off means what? It is cut off. Okay, that means what? It is you see, that is the place where you come to this figure here. You see, this is the cotter, and you see, this cotter is strong, we assumed, so it fails on that place and this place. These two places it fails, and this, like a cake piece, it falls off. So for that, where it should fail, the entire area, this shaded area. Okay, this is the should fail. You see, the diameter is d1, and this the spigot end is subject to the double shear. See, it is not shear, it's a spelling mistake. Shear along the two planes containing two surfaces of the cotter as shown in figure. So that is one place where it should cut off there here, and then only that cake piece, like a piece, it will fall. See, that is where a mouse is there, that is the cotter. Okay, when it is being pulled that side. So because cotter is in the middle, cotter is there. Okay, so it will fail. That is the diameter d1, this is the length a, the area will be d1 into a, d1 into a. two surfaces, up also, down also. You see, up down means in the top view it is shown like that. So the area under shear or resisting area will be equal to 2 times d1 into a, because double shear. Double shear means 2 times you take. So shear stress top is given by load upon area. See, that is P upon 2 d1a. So here d1 is already known, and you can find out a from this equation. Tau will be given, p will be given in the problem, or you can find out tau value from the data book. For you, data book is not allowed in the exam, so it will be given, it should be given. Okay, and for that's how you will find out, because d1 is already known, calculated before. We will find out what is a. Okay, now coming back to our our figure, we see this is the spigot. The entire all the dimensions of this spigot are found out. Diameter rod and rod diameter. You see the socket side we didn't find out anything. You see cotter only thickness of T we found out. Otherwise, spigot dimensions all are found out. We found out what is the rod diameter D, and what is the socket spigot diameter D1, and the thickness T, and the spigot collar diameter D2. We have found out, and what the length of the T1, and also this length A of the rod end, the spigot rod end, we have found out. These are the dimensions of uh, the socket end. Okay, this rod we considered failure in tension. That also we considered in tensile failure across the slot. Okay, and then uh, we have considered D1, D2 for finding out. We considered the crushing failure of the spigot collar against the socket collar. We found out D2, and here we considered crushing of the spigot rod end against the cotter. Also, we got two values of D1. Okay, with two equations, greater will value we took, and then we found out what is T1 considering the shearing failure of the spigot collar. And finally, we found out what, considering the shearing failure of this rod end, in double shear it failed. Uh, so we considered shearing failure across the cotter. We found out A. So these are the dimensions we have found out. Okay, we will not, we'll stop here, because this much you should be able to understand. Okay, thank you.